Hello, and welcome to another edition of Tech Tidbits. My name is Brandon, and today we'll be discussing the 7-layer OSI model. Now, a little bit about the OSI model. The OSI model is a reference model, one that you'll need to get very familiar with if you plan on taking your networking career seriously. Basically what it is a reference model. It allows us to break the different networking components up into smaller pieces so we can work on those individual pieces and parts and not interfere with the other parts. It simplifies things like working on the network. It simplifies troubleshooting, breaking it down into smaller processes. It makes it so manufacturers can make parts that function at one part, such as routers, which function at network layer, layer 3, or switches, which function at the data link layer, layer 2. Okay, so with that said, let's pull up the OSI model so we can actually see what it looks like. Here it is, our beautiful OSI model. Starting with this layer number 7 and going down to layer number 1. Layer number 7 is the application layer. The application layer handles things such as the way the application that you're using interfaces or requests the use of the network. So that's going to be the application's way or the user's way to interact with the network through the application layer. The presentation layer is a neat one. The presentation layer handles the way data is formatted. Now, you may be used to things such as HTML or JPEG or MP4 files, whatever you're used to. Those files are actually generic files. They're generic file formats, meaning that whatever's using the network is going to be able to understand those formats. So the presentation handles the way those formats are created and presented. The presentation layer also handles authentication, which is like usernames and passwords and such things like that. Next, we have the session layer. The session layer keeps information from different applications separate. So it basically keeps applications data separate from other applications. So just keep that in mind. Those top 3 layers of the OSI model, those are all take place typically within the computer. Next, we'll be going through the transport, the network, the data link, and the physical layer. All those layers are layers that handle the way the network communicates and the way the computer sends data from one computer across the network to another computer. The transport layer handles something called TCP and UDP communication. TCP being what's called reliable communication, and UDP being what's called unreliable communication. Now, reliable meaning basically that there's going to the reliable or TCP is going to make sure that your data reaches its destination, and I'll hit briefly on that while we're talking about it. Network, the network layer. The network layer is very important. It handles one single protocol, really, well, a couple, but one being really important, which is IP. So IP addressing, the way the end-to-end communication works, is all handled there at the network layer. The data link layer handles the same thing that the network layer handles, but locally. So your local communication from machines on the same network as your machine that you're using, those are going to be communicating through the data link layer. Things such as MAC addressing, the hardware addressing, the burned-in address, whatever you want to call it, that's where you'll find that at the data link layer. The data link layer also handles what's called, it has something called an FCS, basically allowing it to check for errors that occurred during transmission, but it doesn't do any error recovery. Error recovery is actually something that's handled by TCP in the transport layer. The next layer down is your physical layer. The physical layer handles the actual transmission of the bits from one device to another device, the physical pinout of cables, all your physical things you can touch, those are all handled down at the physical layer. So keep that in mind. Now, this is going to be a quick video because I want to keep it short, so try and follow along with me as we go through this. So we have this computer here, which is going to be, let's give them an IP address real quick. We have this computer, which is going to be, we'll call it 11.5.5.5. will be its IP address. And we have this server. The server's address will be, oh, let's call him, what's a good address for a server? Let's call him, oh, I'm having trouble coming up with the address. 211.5.5.8 will be his address. Don't ask. That's just what I came up with. I want you to assume something here for me, that this is going to be our subnet mask right here. Now, I'm assuming that you already know what subnet mask is. If not, this video might be a little bit ahead for you. And we'll be doing another video that just focuses on how the addresses themselves are made up. Now, this computer wants to communicate with this computer. So the very first thing it's going to do is going to compare the network portion of its address with the network portion of the address that it's trying to reach. Well, first, what's going to happen is, let's say it like this. Let's put a little bit more information into it. We'll call this server www.m24solutions.com. So that will be the name of our server. Okay? So just follow along with me. Bear with me for one moment while I change this right here, because this guy should actually be over here. Okay. So our server over here is going to be www.m24solutions.com. So over here, somebody types in the web page, www.m24solutions.com. This computer has no idea what that means. So basically, this computer here is going to do something called requesting the information from a DNS server. So we'll say that our DNS server is going to be over here. Let's just make him up real quick. This is our DNS server. So the computer is going to go to the DNS server and it's going to say, hey, DNS server, what is the address for www.m24solutions.com? Now, the DNS server knows this information, so it gives it back to the computer and says, hey, m24solutions.com can be found at 211.5.5.8. So with that information in hand, the computer is going to say, great, looking at this information, I can see that the network portion of that address, which is just this information right here, the 211.5.5, does not match the network portion of my address, so I need to go to the next router or to my default gateway to reach that. So what it's going to do is going to take its HTTP request at the application layer and put it in an application layer or a layer 7 PDU. So that HTTP GET request is going to go down to the presentation layer where it's going to get generically formatted. It's going to go down to the session, get put in a separate session. Now the area I want to focus on is the transport layer. In the transport layer, you get assigned a few things here. First of all, since we're using Internet Explorer, it's coded to use TCP. So it's not going to use UDP, so we'll explain that later. So it uses TCP, and it needs to reach the HTTP on the server. Since the server uses HTTP, the HTTP is actually going to be port 80. Okay? So it's going to get TCP port 80 on this side. So here at the transport layer, it gets assigned TCP port 80. It's a reliable communications because it's using TCP. It also gets something called a source port. A source port, the TCP port 80 is the destination port. The source port on this is actually going to be chose dynamically by the computer itself, and it's going to be somewhere probably up in the high thousands. So it's just a random port, just so when the server here knows when to communicate back to this computer, which port is actually going to send that information to. Now we're running out of time here, so excuse me if I'm going a little bit fast. So we'll say that the source port or here is 1104. So that just be a random source port. The next thing that's going to happen down here is at the network layer. The network layer is the TCP gets encapsulated in the data at the transport layer, and that gets handed down to the network layer where that data is broken down into packets. It's also given a source and destination IP address, with the source being the source IP of the host, which was 101.5.5.5, and the destination address being 211, and that's the destination of the server. Again, I'm sorry for going so fast. I gotta keep this video short. So at the data link layer, you also get a source and destination address. Now, at the data link layer, the source address is going to be the source MAC address of this computer. So whatever the source MAC address is, that's encoded, hard-coded on the MAC, the network interface card, is going to be up in there, and it's going to be hexadecimal and formatted something like what you see up under the computer at the top. So we'll say that this destination address is AF 0112 43 EE 11. So the source MAC address will be the same, the source MAC address of this computer here, and that's going to get put down into the data link layer down here as being the source for it. So that will be the source, and the destination address will be the destination address for whatever the destination MAC address is of, what do you think? Not the server. It will not be the destination address of the server, but it will be the destination address of the default gateway. Now, the default gateway is going to be like your router or whatever your computer needs to communicate to get out of its local area network. So your default gateway will be blah, 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 blah. There won't be any of those letters. But it'll be whatever it is for the next computer that, or the next default gateway that it has to reach. Now, this is important to remember this concept, and you got to keep this in mind. When transferring information across the network, the network's going to use two different addresses. It's going to use the data link, which is used to get information across locally, and the network addresses, which is used to get it across from end to end. Now, the network addresses don't change ever. Your network address stays the same from the time it leaves the computer. The data link information, this information here, gets ripped off at every single device it goes to. So once, this is just to get it to the next device. When the default gateway or your router receives this information, it's going to look here and say, hey, that's my destination MAC address, so it was meant to go for me. Let me rip this information up or open this package up and look deeper inside of it. And when it looks inside of that frame from the data link layer, it sees the source and the destination IP address, and sees that that destination IP address was for this guy here and not for it. So what it will do is it will package that request inside another frame that's to send it to the next hop or the next point in the destination that it has to go to in order to reach that address. So we'll continue to do that, continue to rip this information off and put new information on it, and rip it off and put new information on it until it reaches here. Then the information that it puts as the source and destination will be the source that it came from in its last hop, and the destination will be the destination MAC address of this server once it reaches that address. Now, at the physical layer, this is all this is encoded into zeros and ones at the physical layer, put on the wire, transfer, and it goes all the way over to the physical layer of the device that's receiving it, and all this gets de-encapsulated as it continues to travel back up the network and go to the server, where after all that happens, the whole process happens again, where the server sends the information back down, back around, and back up to the computer. Now, this information, things that you should know real quick before I run out of time. When it sends the information back, the destination that server will use for the computer, keep in mind, will at TCP will be the source that the computer created dynamically when originally creating the data. Well, that's a quick run through of OSI. I'm sorry it was so short, but I got to keep it down to 15 minutes. And if you want to know more information, or if you want to learn anything particular, if you have any questions or would like me to fine tune or go over anything, leave it in the comments and I will create videos tailored specifically for your needs. Thank you for watching and have a great day.